This is the 6th video on differentiation, where we're going to have a look at how we can use differentiation to help us to work out the equation of tangents or normals. First of all, normal, basically that means the perpendicular line to the tangent. That's what a normal means. We'll have a look at an example of that in a minute. So, first of all, we want to find the equation of the tangent of the curve y equals 3x squared minus 9x plus 10, and we want to work out the equation of the tangent when x is 2. So, here's a sketch of that function. So when x is 2 here, I want to work out what's the equation of that tangent. So what's the equation of the tangent here, basically? So to do so, it's a tangent, it's going to be a straight line. So I need to do y equals mx plus c, so I need the gradient first of all. So let's differentiate this so we can work out the gradient. So when I differentiate this, I'm going to get 6x minus 9. So the gradient at this point, so substitute 2 into this, so that's going to be 12 minus 9. Okay, so the gradient at this point is 3, which kind of makes sense from the little sketch that I've drawn there. Okay, so I know it's going to be y equals 3x plus something. In order for me to work out that something, I need to know the coordinate that this tangent passes through. Well, I already know the x coordinate. I need to know the y coordinate, so what's the y coordinate at this point? I think we can read off from my diagram here it's 4, but if you're not sure, or if we didn't have the diagram, if I just substitute 2 into my y function here, I'll get the y coordinate. So substituting 2 in here, that's going to be 12 minus 18 plus 10, which is 4. So when x is 2, y is 4. So substituting that in here then, 3 times 2. And now I can see that my c is minus 2. And so the equation of the tangent at that point is that. Which kind of makes sense from my sketch, because I think it's going to cut through down here. If I continue my line, it's going to cut through at about minus 2. So my rough drawing there actually wasn't too far off the exact answer. So equation of tangent, it's a straight line, so y equals mx plus c. Differentiate so you can get the gradient. Make sure you've got the coordinate. Use this to help you if you need. And then substitute in to get the y-intercept. Second example. We want to work out the equation of the normal. So this curve, which is y equals 8 minus 3 root x at the point when x equals 4. So at x equals 4, that's this coordinate here. So my tangent at that point is going to look something like that. So the normal will be perpendicular to that. So what I'm looking for is what's that equation? Where they are perpendicular. Okay, so it's a straight line, y equals mx plus c. I need to know the gradient of the tangent first. I can then do the negative reciprocal to get the gradient of my normal. I then need to make sure I know what that coordinate is, so I can then get I can then finish the equation off. So, to get the gradient of the tangent, first of all, I need to differentiate that. In order for me to differentiate that, I need to write this in index form. So I'm going to say y equals 8 minus 3x to the power of a half, because the square root, same thing as pounds a half. Differentiate this to dy by dx. The 8 disappears, the minus 3 gets times by a half, so I get minus 3 over 2. The half times half minus 1 is minus 1 half. So I get that, which I'm going to rewrite as being minus 3 over 2. I'm going to move this to the bottom, like, oh. I'm going to move that. The minus power moves it to the bottom, the half, same thing, square root. The reason I'm writing it like that is just to make it a bit easier for me to substitute the 4 in. Because that's what I want to do. I want to work out the gradient when x is 4. So if I substitute 4 into this, I get minus 3 over 2 times the square root of 4, so 2 times 2 is 4. So this is the gradient of my tangent, which means the gradient of my normal is the negative reciprocal of that, so that's going to be plus 4 over 3. Okay, I need to know the coordinate. So I know the x coordinate, I need to know the y coordinate. So if I substitute 4 into my y function, so y equals 8 minus 3 times the square root of 4. So 3 times 2 is 6, 8 minus 6 is 2, which makes sense from the diagram. So y is 2 when x is 4. So 16 over 3 plus c. Get myself a common denominator, so 6 over 3 minus 16 over 3. So c is minus 10 over 3. And so my final equation then is y equals 4 over 3x minus 10 over 3. I said that's a final equation, but it's a little bit messy with these fractions here, so I might times all the way through by 3 so I can get integers. So 3y equals 4x minus 10. And I'll probably leave my answer like that. I could take the 3y over there so everything's together on one side if I wished. But it depends on what the question's asking you to leave your answer as. So the important thing is, tangents and normals, they are both straight lines, they both obey the y equals mx plus c. You need to know the gradient, so if you differentiate the curve, that's going to give you your gradient function. So differentiating the curve gives you a gradient function. If you want the gradient at that point, so substitute your x value in, to get the gradient at that point. That would be the gradient of the tangent. Do the negative reciprocal to get the gradient of the normal. If you're working out the equation for normal, negative reciprocal. And the only other thing you need to get the equation of a straight line is a coordinate that it goes through. So if they've not told you the whole coordinate, substitute the x value back into your y function to get the y coordinate. That's it.